So we go on to non-homogeneous equations. Recall a linear non-homogeneous equation is of the form a(n)x, nth derivative, a(n minus 1x, n minus first derivative, all the way up to a1x, first derivative, plus a0x, y itself. And that equals g of x. And we know how to find the solution of a non-homogeneous equation. There are two parts: the complementary function, the complementary solution, and the particular solution. So the key is to find the final solution, and it is the sum of the complementary solution yc and the particular solution yp. The i.e. y is equal to yc plus yp. The objective of the method of undetermined coefficients using superposition approach is to find the particular solution. And you may ask me, well, what about the complementary solution? We know the trick that we have used thus far. If we want to find the complementary solution, it has arbitrary constants, and we find the solution corresponding to the complementary solution by treating the given non-homogeneous equation as a homogeneous equation, and we can use the method of constant coefficients with the homogeneous equation to find the complementary solution. So the first step is to find the complementary solution using the method of constant coefficients. Once we find the complementary solution, the second step is to find the particular solution using the method of undetermined coefficients. Specifically speaking, in this case, we are going to use the superposition approach. Now, the key thing to note here is that the superposition approach is not, I don't want to use the word precise or accurate, I should say not effective, in the sense it requires thoughtful guesswork. Now, when I explain in the next page, you would see what I mean by thoughtful guesswork. We have to guess the form of the particular solution to find the actual particular solution. That is, we have to identify the form of particular solution. So the table here summarizes all or most of the functions that we would encounter and the corresponding form of the particular solution. So for instance, if the right hand side is just a constant, we say the form has to be a. If it is a linear function, we say it is ax plus b. If it is a quadratic function, the right hand side g of x, then we use ax squared plus bx plus c. If it is a cubic function, we go for ax cubed plus bx squared plus cx plus e. And if it's sine x or sine 4x, we use a cosine 4x plus b sine 4x. If it happened to be simply sine x, then we would use a cosine x plus b sine x. If we have cosine 4x, we would use a cosine 4x plus b sine 4x. If we have a combination of a linear function and an exponential function, then we would use ax plus b times e raised 5x. If we simply have an exponential function e raised 5x, we would use a times e raised 5x. If we have a quadratic function multiplied by an exponential, we have ax squared plus bx plus c multiplied by e raised 5x. And if we have e raised 3x, you can see I have a e raised 3x cosine 4x plus b e raised 3x cosine 4x. And if it is of that form, where x squared is a quadratic function, and then I have a sine function, so I have to use ax squared bx plus c cosine 4x, ex squared fx plus g sine 4x. If I have x, which is a linear function, multiplied by e raised 3x, multiplied by cosine 4x, I have to use ax plus b, exponential, corresponding to the e raised 3x part, cosine 4x, and the same thing, cx plus e raised 3x sine 4x. The reason for that is we use the cosine 4x and sine 4x term because I see cosine 4x. I use the e raised 3x here because of the e raised 3x in g of x. And I use ax plus b because of x that I see. And if we use the same idea, and for example, if we had g of x is equal to x squared e raised x cosine 2x, then the form of yp would be yp equals ax squared plus bx plus c, corresponding to the x squared part, e raised x, corresponding to the e raised x part, cosine 2x, corresponding to the cosine 2x part, but I need to have sine 2x also anytime I see cosine 2x or sine 2x. So we would have ex squared plus fx plus g multiplied by e raised x multiplied by sine 2x. So you can see that things can get complicated really fast when we try to do the method of undetermined coefficients. You may ask me, well, where does the name undetermined coefficients come from? The A, B, C, well, I forgot D, but that's okay. E, F, G, those are all the undetermined coefficients. And our objective is to find those undetermined coefficients. Now, there is an issue here when we use the method of undetermined coefficients. The first case is pretty much easy. The case 1 is we refer to this table and we identify a form, or use the simple rule, the form of yp is a linear combination of independent solutions that are generated by differentiating g of x repeatedly. And a word of caution, the particular solution cannot have any function that is duplicated in YC, because it would become linearly dependent. So we cannot have duplicated functions in the complementary solution. So that results in case 2. If there is a possibility that the particular solution has duplicated functions that have appeared in YC, then we have to use then we multiply every duplicate by x raised n. So we multiply by x, x squared, x cubed, and so forth. And that is how we would obtain the particular solution. So let's start with a simple case. So this is a differential equation which we want to solve using the method of undetermined coefficients. So the first step is to write out the associated homogeneous equation. Y double prime minus 10y prime plus 25 equals 0. And we know how to solve that because we have constant coefficients. So the auxiliary equation is m squared minus 10m plus 25 equals 0. Which would simply mean m minus 5 times m minus 5 equals 0. So the two roots are m1 equals m2 equals 5. We set the first factor equal to 0, we set the second factor equal to 0, and we end up getting a solution. The roots. So here the roots are real and repeating, so which would imply the complementary solution is c1 e raised 5x plus c2 x times e raised 5x. The next step is to find the particular solution. So g of x in this case is 30x plus 3. So you look at that and you realize that that is a linear function of the form ax plus b or mx plus b, what say you? And we know if the right hand side is linear, then according to the chart that we have here, we have to pick ax plus b. So we are going to conclude that the yp is of the form ax plus b. Now, how do we find a and b? Here, a and b are the undetermined coefficients. So to do that, we are going to make use of the given g of x to find the corresponding values of a and b. So what we have to do is we have to start with yp, which is ax plus b, and this is a second order differential equation. So yp prime would simply be a, and yp double prime is 0. And the equation that we have, so plug in yp, yp prime, and yp double prime in the given dE, which is y double prime minus 10y plus 25 equals 30x plus 3. So let's start with the left hand side. So we have y double prime to be 0 minus 10 times y prime plus 25y. Yp prime is a plus 25y, which is ax plus b. And that would be equal to 30x plus 3. Distribute and simplify 10a or negative 10a plus 25ax plus 25b equals 30x plus 3. So 25a multiplied by x plus 25b minus 10a equals 30x plus 3. So what we're going to do is we're going to make a direct comparison. We're going to equate 25a to 30 because it is the coefficient of x, and 25b minus 10a to 3. For 25a is 30, a is 30 over 25, which is 6 over 5. And we know 25b minus 10a equals 3, which would imply 25b minus 10 times a is 6 over 5 equals 3, which would imply 25b minus 12 equals 3. 25b equals 3 plus 12, which would mean 25b equals 15. Divide by 25 on both sides. b is 15 over 25, which is 3 over 5. So the particular solution, yp, we know that it is of the form ax plus b. We found a, which is 6 over 5x. We found b, 3 over 5 times 1. We have 1 over 5 in common. If I pull that out, I have 1 over 5 times 6x plus 1. So the final solution is y equaled yc, which we found earlier here, that is yc, plus the yp that we just found, 1 over 5 times 6x plus 1. And that is the answer. So here we have a function which has a particular solution, non-homogeneous equation, and g of x here is 100x squared minus 26x times e raised x. So first, we have to write the associated homogeneous equation. And that would be y double prime minus 8y prime plus 20y equals 0. So the auxiliary equation is m squared minus 8m plus 20 equals 0. Now we would like to know if we can find the auxiliary equation or the roots of the auxiliary equation. We need to get 20 and we have negative 8m. The question to ask is, would we be able to factor this? Probably not. Might have to be minus 20. If it's plus 20, it is going to give us troubles and it wouldn't match the right hand side. So let me verify this problem quickly. It is plus 20. So let's find the roots. Minus b, b squared, minus 4 times a times c, divided by 2a, it's 64, plus or minus, 8, plus or minus, square root of 64 minus 80, divided by 2. If I pull 16 out of the root, I'd have 4 square root of negative 1 divided by 2. And if I simplify, I have 4 plus or minus 2. Square root of negative 1 is simply I. So we know that this is alpha, that's beta. So the complementary solution y equals e raised alpha x multiplied by Now that we have a complementary solution, we could find the particular solution using the function g of x. So we know g of x is equal to 100x squared minus 26x e raised x. So the form of particular solution is yp equal to ax squared plus bx plus c, because I see an x squared term, minus 26 dx plus e. Oh, sorry, I don't need the 26. Dx plus e. If we have a constant, we don't have to specify the constant. The reason why I put a linear form is because I have x and multiply that by e raised x. And that is the form that I'm assuming for the particular solution. So now we have to find the derivatives, plug it in the original dE, and find the undetermined coefficients a, b, c, d, and e. So yp prime would be 2ax plus b, derivative of the constant is 0, minus dx plus e times e raised x plus e raised x multiplied by d. I'm using product rule for that part. There should be a minus there. So that is product rule for the dx plus e term right here. I guess I'd go ahead and simplify this. 2ax plus b minus dx e raised x minus e times e raised x minus e raised x times d. 2ax plus b minus dx e raised x minus d plus e raised x. That is the first derivative. The second derivative is 2a, derivative of b is 0, minus d, product rule again, x e raised x plus e raised x times 1 minus d plus e raised x. We could go ahead and simplify this. 2a minus dx e raised x minus d e raised x minus d e raised x minus e raised x. When we combine those, we have 2a minus dx e raised x minus 2d e raised x minus e raised x. We take all these and plug it in the equation. So plug in yp, yp prime, and yp double prime in the given dE. So we have yp double prime minus 8 yp prime plus 20 yp is equal to 100 x squared minus 26x times e raised x. I'm using yp instead of y because I know that the particular solution will satisfy the differential equation. So 2a minus dx e raised x minus 2d e raised x minus e raised x minus 8 times the first derivative 2ax plus b minus dx e raised x minus d e raised x minus e raised x plus 20 times yp. Yp is simply ax squared plus bx plus c minus dx e raised x minus e raised x equals 100x squared minus 26x e raised x. So we have to do some algebra here. 2a minus dx e raised x minus 2d e raised x minus e raised x minus 16ax minus 8b plus 8dx e raised x plus 8d e raised x plus 8e raised x plus 20a x squared plus 20b x plus 20c minus 20x e raised x minus 20e raised x equals 100x squared minus 26x e raised x. Combine the constant terms. We have 2a. The b term is minus 8b plus 20c. We have a whole lot of e raised x terms. So we have e raised x, have minus 2d minus e plus 8d plus 8e minus 20e. I believe that is it. If I have the signs right. Yes. X e raised x terms, I have minus d plus 8d minus 20 by itself let me see, feels like missing a term here. Forgot the d here. It's 20d. Got to be extremely careful when you do this, or else it's just trouble. Feel like I'm missing another term. Dx e raised x, okay. Okay, and dx e minus 21. Okay, so those are the d terms with the x e raised x. The x squared term, we have only one, so 20a x squared. X term, we have only one, which is 20b x. What else do we have? Oh, we actually have two of them. So minus 16a plus 20b times x. So let's count the terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have accounted for everything. Now we could simplify. So 2a minus 8b plus 20c plus e raised x, 6d minus or plus 7e minus 20e is minus 13e plus x e raised x, 8d minus 20d is minus 13d plus 20ax squared plus negative 16a plus 20b multiplied by x equals 100 x squared minus 26 x e raised x. So we simply have to equate the terms corresponding to each of the functional terms, so x squared, x e raised x, and x e raised x. So 20a would equal to 100, and negative 13d would equal to negative 26. So a would be 5, and d would be 2. But you can't simply say the other coefficients are 0. What we have to do is, since there isn't a constant term on the other side, we have 2a minus 8b plus 20c equals 0. Since we don't have an e raised x term on the other side, 6d minus 13e would equal 0. Since we don't have an x term on the other side, negative 16a plus 20b equals 0. Now, I know that d is 2 already, so since I know what d is, I can find e easily. So use d equals 2 in 6d minus 13e equals 0. So 12 minus 13e would equal 0. 6 times 2 is 12. Minus 13e would equal minus 12, which would mean e is 12 over 13. So we found e. Since we know a already, we could plug in a, so negative 16 times 5 plus 20b equals 0. So I'm plugging in so 20b would equal to positive 80, which should imply b is equal to 4. So we have a, we have b, we have d, we just have to find c. So to get c, we're going to use that equation. So 2 times a, which is 4, minus 8 times, that's 5. Plug in a equals 5, b equals 4, in 2a minus 8b plus 20c equals 0. So 2 times 5 minus 8 times 4 plus 20c would equal 0. 10 minus 32 plus 20c equals 0. 20c would equal to positive 22. C is 11 over 10. So we found all the constants, so the particular solution the form that we started with was ax squared plus bx plus c, and we had dx plus e times x e raised x. So we plug in all the values, 5x squared plus 4x plus 11 over 10 plus dx, 2x, plus 12 over 13 e raised x. So the final solution is y equals yc plus yp. We know what yc is, that is e raised 4x multiplied by cosine x plus sine x plus 5x squared plus 4x plus 11 over 10 plus 2x plus 12 over 13 e raised x. And that would be the final solution. So here we have a second order non-homogeneous equation. And we want to find its solution using the method of undetermined coefficients. So the starting point, as always, is to start with the associated homogeneous equation. So the associated homogeneous equation is y double prime plus y equals 0. Oh, it's 4y, sorry, plus 4y equals 0. Now we know how to solve this. This is a linear homogeneous equation, second order. We could use the method of constant coefficients to find the solution. So the auxiliary equation is m squared plus 4 equals 0. And that is a quadratic equation, and we could find its solution easily. This would imply m squared equals minus 4. M would be square root of minus 4. That is simply plus or minus 2i, which would imply alpha is 0 and beta is 2. And we know that the solution, in this case, the complementary solution, is y equals e raised alpha x, c1 cosine beta x plus c2 sine beta x. We found beta to be 2, alpha is 0, so e raised 0 x, c1 cosine 2x plus c2 sine 2x. That would simply give us c1 cosine 2x plus c2 sine 2x. Now that is just the complementary solution, and we have to find the particular solution now. So I look at g of x. Since g of x is 3 sine 2x, the guess in superposition approach here is that the particular solution is of the form yp equals a cosine 2x plus b sine 2x. if you forget this, you could always go back and look at this table. This is sort of a reference table that helps us identify what to use, and you can see item number 5 or 6 that tells us that we have to use a cosine to x and b sine to x in this case. So now we find yp prime, which is minus 2a sine to x plus 2b cosine to x, yp double prime minus 4a cosine to x minus 4b sine to x, and we have to plug in yp double prime and yp in the original differential equation, which is yp double prime plus 4yp equals 3 sine 2x. So yp double prime is minus 4a cosine 2x minus 4b sine 2x, and yp is 4 times a cosine 2x plus b sine 2x, and that would equal to 3 sine 2x. So we have minus 4a cosine 2x minus 4b sine 2x plus 4a cosine 2x plus 4b sine 2x equals 3 sine 2x. Now, I did this to demonstrate something. Now, you can see we end up getting 0 equals 3 sine 2x. Now, that doesn't make any sense, so that has to be wrong. Now, why did this happen? This happened because sine 2x is already part of the complementary solution. In other words, sine 2x is duplicated in the complementary solution. So how do we go around that problem? We have to have the particular form must have the form, or the particular solution yp equals x times a cosine 2x plus b sine 2x. I wanted to demonstrate this key feature. We look at the solution, the complementary solution, and it already has sine 2x, and we can't expect the same thing to repeat directly in the particular solution. If you did that, you would end up with a situation like that equation, so that is due to duplication. So this is where we multiply by x. So yp prime now would be x times minus 2a sine 2x minus 2b cosine 2x plus a cosine 2x plus b sine 2x multiplied by 1. Yp double prime is x times minus 4a cosine 2x minus 4b or plus 4b sine 2x so that should be plus and this should be minus, sorry, plus minus 2a sine 2x plus 2b cosine 2x multiplied by 1, that's product rule, and the last term minus 2a sine 2x minus 2b cosine 2x. Let's simplify before proceeding. We would have minus 4ax cosine 2x minus 4bx sine 2x minus 2a sine 2x plus 2b cosine 2x minus 2a sine 2x minus 2b cosine 2x, that would be y double prime. And plug in yp double prime and yp in the original DE. So we would have minus 4a x cosine 2x minus 4bx sine 2x minus 2a sine 2x plus 2b cosine 2x minus 2a sine 2x minus 2b cosine 2x and yp, which is xa cosine 2x plus bx sine 2x, and that would equal to 3 sine 2x. So combine all the cosine terms and the sine terms. So x cosine 2x is our first term, and that would give us the equation minus 4a plus a, and that's all we see, so which would give us minus 5a. And over here, x sine 2x would give us minus 4b plus b. The sine 2x terms, we have minus 2a, minus 2a. The cosine 2x terms simply disappear, so we'd end up having that equal to 3 sine 2x. Okay, so that would simply mean the cosine 2x term, there is a cosine 2x term that gets cancelled. So minus 4a sine 2x would equal to 3 sine 2x. So a would be negative 3 over 4 sine 2x. And obviously b has to be 0 because we don't see any x cosine 2x terms or x sine 2x terms, so they'd all be 0. So the particular solution in this case would simply be yp is equal to minus 3 over 4 cosine 2x. So the solution to the DE is the complementary solution, which we found earlier, and we have to multiply this by x, which is cosine C1 cosine 2x plus C2 sine 2x, and the particular solution 3 over 4 x cosine 2x. So here we have another differential equation, non-homogeneous second order. So the first step is to come up with the associated homogeneous equation, which is y double prime plus 2y prime plus y equals 0. So the auxiliary equation is m squared plus 2m plus 1 equals 0. So we have to find the root of this equation. We can find the roots using the quadratic formula, or we could use factoring. And in this case, it is easy to see that m plus 1 times m plus 1 will result in that auxiliary equation. This would imply m1 equals m2 equals minus 1. So what we have here is repeated roots, and they are real. So the complementary solution is yc equal to c1 e raised minus x plus c2 x e raised minus x. That part is done. Now we have to move on to the non-homogeneous part. So the non-homogeneous part is due to the g of x that is on the right hand side. So we know g of x is equal to sine x plus 3 cosine 2x. So the particular solution is of the form yp equals a times sine x plus or a times cosine x plus b times sine x, corresponding to that part, plus c cosine 2x plus d sine 2x, corresponding to that part. So that is the particular solution that I am going to guess. I'm going to suggest based on, what we see on the right hand side. Now we have to find the derivatives. Yp prime is minus a sine x plus b cosine x minus 2c sine 2x plus 2d sine 2 cosine 2x. Yp double prime is minus a cosine x minus b sine x minus 4c cosine 2x minus 4d sine 2x. Now we plug in yp prime, yp double prime in the original dE, plug in yp double prime, yp prime, and yp in yp double prime plus 2 yp prime plus yp equals sine x plus 3 cosine 2x. So we will have minus a cosine x minus b sine x minus 4c cosine 2x minus 4d sine 2x minus 2a sine x plus 2b cosine x minus 4c, I'm doing 2 yp prime, 4c sine 2x plus 4d cosine 2x, and yp is a cosine x plus b sine x plus c cosine 2x plus d sine 2x equals the right hand side, which is sine x, plus 3 cosine 2x. So combine all the cosine x terms. I have minus a and 2b, another a, so these two would go away. So I have 2b cosine x sine x terms, those two would go away, and I have minus 2a sine x cosine 2x terms. I have minus 4c and a c and a 4d, so plus cosine 2x minus 4c plus 4d plus c, so 1, 2 and 3, sine 2x terms minus 4d minus 4c plus d equals sine x plus 3 cosine 2x. So by direct comparison, we can see minus 2a is equal to 1. Comparing the sine x terms, comparing the cosine 2x terms, I would get cosine minus 3c plus 4d equals 3. I don't have any sine terms, sine 2x terms, so minus 3d minus 4c would equal 0. And 2b, there isn't a cosine x term on the other side, so 2b would equal to 0. So we know b is 0, a is negative 1 over 2. Now we just have to solve for c and d. I'm going to multiply, let me rearrange the equation. I have a system in two coefficients. I'm going to multiply the first equation by 3. Second equation by 4. add them together. Minus 25c would equal 9. c is minus 9 over 25. Now that we have a value for c, we take that and we plug it back in one of the two equations to get the value of d. So I'm going to use the second one. So this would imply minus 3d minus 4c equals 0. Minus 3d minus 4 times minus 9 over 25 equals 0. Minus 3d would equal to 36 over 25 with the minus. This would go away and I could cancel, which would mean d is 12 over 25. So we found a, b is 0, c is negative 9 over 25, d is 12 over 25. We take all of that and plug it in the form that we identified earlier, which is that. So the particular solution, yp, is equal to a, negative 1/2 cosine x, b, which is 0, multiplied by sine x, c, cosine 2x, d, sine 2x. So yp is minus 1/2 cosine x, minus 9 over 25 cosine 2x, plus 12 over 25 sine 2x. Therefore, the solution to the DE the final solution is y equals c1 e raised x, or I believe it's minus x. Yes, it's minus x, plus c2 x e raised minus x, that is yc, plus whatever we found as the particular solution, minus 1/2 cosine x, minus 9 over 5 cosine 2x, plus 12 over 25 sine 2x. So once again, we have a second order DE. So the associated homogeneous DE is y double prime minus y prime plus 1 over 4y equals 0. The auxiliary equation is m squared minus m plus 1 over 4 equals 0. And we'd like to find the solution to that equation. It's best, I'm perfectly fine with fractions, but some people don't like fractions, so we can eliminate that fraction by multiplying by 4 on both sides. So I'd end up getting 4m squared minus 4m plus 1 equals 0. We could use the quadratic formula. So m would be equal to minus b, minus of minus 4, plus or minus b squared, minus 4 squared, minus 4 times a times c, divided by 2 times a. The term inside the root is 0, so we have 4 over 2 times 4. Which would simply give us 1 over 2. So here we have m1 equals m2, equals 1 over 2. The roots are repeating and they are real. So the complementary solution is yc equals c1 e raised x over 2 plus c2 x e raised x over 2. So now we want to find the form of the particular solution. Now you have to look at g of x, of course. G of x is 3 plus e raised x over 2. So yp, I see 3 over there, so I can simply put a constant, but I can't put b times e over x over 2, e raised x over 2, because I have that term already in the complementary solution. That's not going to work. You may say, okay, I'll do x times e raised x over 2, so b x times e raised x over 2, and that is here also. So we can't use both of them, so we're going to take or move on to the next step and say bx squared e raised x over 2. So that is the form that I am going to use for my particular solution. So now we have to find yp prime, which is 0 plus b x squared over 2 e raised x over 2 plus e raised x over 2 multiplied by 2x. So b over 2 x squared e raised x over 2 plus 2 times x e raised x over 2. Yp double prime is b over 2 x squared over 2 e raised x over 2 plus e raised x over 2 multiplied by 2x. I'm using product rule, plus 2 times x over 2 e raised x over 2 plus e raised x over 2 times 1. Product rule again. That would give me b over 4 x squared e raised x over 2 plus b x e raised x over 2 plus x e raised x over 2 plus 2 e raised x over 2. Now have to plug in yp double prime, yp prime, and yp in the given dE, which is y double prime minus yp prime plus yp over 4. Again, you may say, why am I using yp instead of y? Because we know that a particular solution will satisfy the original dE. So that would equal to 3 plus e raised x over 2. So I will have b over 4 x squared e raised x over 2 plus bx e raised x over 2 plus x e raised x over 2 plus 2 e raised x over 2 minus b over 2 x squared e raised x over 2. I forgot the b there. Minus 2bx e raised x over 2. And lastly, yp. Yp is a over 4 plus b over 4 x squared e raised x over 2. equals 3 plus e raised x over 2. So now we have to make a direct comparison on the left-hand side and the right-hand side. So let's group the x squared e raised x over 2 terms first. So b over 4 minus b over 2, and I have another b over 4, and that is it. The x e raised x over 2 terms, I have b minus 2b plus 1, and e raised x over 2 terms, I have 2, I believe that is it. So I missed a term here. B over 2. Oh, my bad. There has to be a B here. So B, and times B. So we would have bx and B. That would be 2b. So in which case, those two terms would simply go away, and we will have plus a over 4 and 2b and that term would go away. And looks like these two terms would get cancelled, and that would become 0 too. So that should equal 3 plus e raised x over 2. By direct comparison, the constant terms, a over 4 would equal 3, and the coefficient of the e raised x over 2 term is 1, so 2b is equal to 1, which would imply a is 12 and b is 1 over 2. So we have the values for a and b. We can take that and plug it back in our particular solution. So the particular solution is yp equals a, which is 12, plus b, 1/2, x squared e raised x over 2. So the final solution, so the solution to the DE is y equals the complementary solution, which is c1 e raised x over 2 plus c2 x times e raised x over 2 plus 1 over 2 x squared e raised x over 2 plus 12. We can pull out the e raised x over 2 and write it as c1 plus c2x plus x squared over 2 plus 12. So we've got to keep in mind that we need to find the solution to the general the original DE by first finding the complementary solution, then finding the particular solution, adding them together to find the solution. So here we have a differential equation, non-homogeneous of course. The right hand side g of x is e raised x multiplied by cosine 2x. So the associated homogeneous equation is y double prime minus 2y prime plus 5y equals 0. The auxiliary equation is m squared minus 2m plus 5 equals 0. And we want to see if we can find a solution by factoring. I don't believe so, so we've got to use the quadratic formula. So using the quadratic formula, m is minus b plus or minus b squared minus 4 times a times c divided by 2a. So m is 2 plus or minus square root of 4 minus 16 divided by 2. So 2 plus or minus, sorry, I went one step ahead, 4 minus 20, square root of minus 16 over 2, which is 2 plus or minus 4i over 2. We get 1 plus or minus 2i. So here we have alpha equals 1 and beta equals 2. So the complementary solution is yc equal to e raised alpha x, which is x, multiplied by c1 cosine beta x plus c2 sine beta x. Now we move on to find the particular solution. The right hand side is g of x equals e raised x cosine 2x. So the form of the particular solution is, you look at that and we can't simply say yp has to be a e raised x cosine 2x plus b e raised x sine 2x, because that is simply a replication of what we have already. Instead of a and b, we have c1 and c2. So that is not the form we need. The correct form is a x e raised x cosine 2x plus b x e raised x sine 2x. Plus 2b cosine 2x plus b sine 2x plus e raised x a cosine 2x plus b sine 2x. Now we have to find the second derivative. That should be 2x. The second derivative is x e raised x multiplied by a cosine 2x. We have to find the derivative, so minus 2a sine 2x minus 4a cosine 2x minus 2b sine 2x plus 2b sine 2x and plus a cosine 2x minus 2a sine 2x plus 2b cosine 2x plus b sine 2x multiplied by x e raised x plus e raised x. Product rule plus e raised x minus a sine 2x multiplied by 2 plus 2b cosine 2x plus a cosine 2x plus b sine 2x multiplied by e raised x. Let's combine and simplify before proceeding. X e raised x multiplied by, can gather all the terms for x e raised x. That should be a cosine 2x, sorry. And plus a cosine 2x minus 2a sine 2x plus 2b cosine 2x plus b sine 2x. And the e raised x terms, a cosine 2x minus 2a sine 2x plus 2b cosine 2x plus b sine 2x minus 2a sine 2x plus 2b cosine 2x plus a cosine 2x plus b sine 2x. So x e raised x multiplied by, let's see, minus 4a sine 2x minus 3a cosine 2x plus 4b cosine 2x minus b sine 2x plus e raised x 2a cosine 2x minus 4a sine 2x plus 4b cosine 2x plus 2b sine 2x. That'll be the second derivative, and we have to plug that in and we have to simplify, and the x e raised x terms would all equate to 0. Now what we want is the cosine 2x terms. So in the second derivative, we have this term over here. Oops. Damn it. 2a cosine 2x. And if we look at it, what we need is the 2a over here and the 4b over there. And in here, we simply need the a. And the original, we simply need nothing. So what we have is simply 2a plus 4b cosine e raised x cosine 2x. So plugging it the other terms would simply be 0. So we have 2a plus 4b multiplied by cosine 2x e raised x. And in the first derivative, we have a cosine 2x, and the equation has minus 2 there, so minus 2a e raised x cosine 2x. So all the terms we need, which would imply the right hand side is e raised x cosine 2x. If we distribute, we have 2a e raised x cosine 2x plus e raised x cosine 2x multiplied by 4b minus 2a e raised x cosine 2x. So those two would get cancelled, and I'll get 4b is equal to 1, which should imply b is 1 over 4. And naturally, if we look at the sine a terms, or the sine terms, we will recognize that a has to be 0. If you look at the sine 2x terms, and if we combine it, we will have minus 4a plus 2b times e raised x sine 2x. And in the first derivative, we have minus 2b e raised x sine 2x. And that must equal to e raised x cosine 2x. I don't want the other terms because that is x e raised x term, and same over here, that'll just be extra terms that we don't need. It's right there, so we don't have to spend time trying to evaluate those terms. So if I look at this and if I combine these two, I would end up getting minus 4a plus 2b minus 2b multiplied by sine 2x e raised x equals e raised x cosine 2x plus 0 times e raised x sine 2x. The 2b and the minus 2b will get cancelled, so those two would simply go away. And since those two go away, I'd have minus 4a e raised x sine 2x equals e raised x cosine 2x plus 0 e raised x sine 2x. So equate the coefficients of that term to that term, we have minus 4a equals 0, which would imply a is 0. Now the key to this problem is not to include the extra terms, the x e raised x, because we don't have coefficients for them, so we don't need that term. So, or those terms involving x e raised x. So what we have here is a is 0 and b is 1 over 4. Plug it in the equation. Yp would then be equal to e raised x multiplied by 0 times cosine x plus 1 over 4 sine x, or is it 2x? I believe it's 2x. 2x multiplied by x. So the particular solution is x e raised x over 4 multiplied by sine 2x. So the final solution is y equals e raised x cosine 2x plus sine 2x plus x e raised x sine 2x. So here we have a third order differential equation, non-homogeneous of course. So the first step is to have the associated homogeneous equation, which would be y triple prime minus 6y double prime equals 0. The auxiliary equation is m cubed minus 6m squared equals 0. If I pull m squared out, I have m minus 6, which would imply the roots are m1 equals m2 equals 0 and m3 equals 6. So the complementary solution is y equals c1 e raised 0x plus c2x e raised 0x plus c3 e raised 6x, which would give us c1 plus c2x plus c3 e raised 6x. So that is the complementary solution. Now we have to go and find the particular solution. So since the right-hand side g of x is 3 minus cosine x, the form of particular solution is yp. I say a constant term, so if we have a constant term, we would say, oh, let's just put a there. But we have already used c1 in the complementary solution. So you may say, okay, let's go ahead and do a times x. But we already have c2 times x in the complementary solution. So the place where we have to start here is a x squared. And since we see cosine x, we have b cosine x plus c sine x. Now we could find the derivatives to find the undetermined coefficients. So yp prime is 2ax minus b sine x plus c cosine x. Yp double prime is 2a minus b cosine x minus c sine x. Yp triple prime is 0 plus b sine x minus c cosine x. Now we plug in yp triple prime, yp double prime. I think those are the only two things we have in this problem. In y triple prime 6 yp prime equals 3 minus cosine x. So that would give us b sine x minus c cosine x minus 6 times 2a it's y double prime. So 2a minus b cosine x minus c sine x equals 3 minus cosine x. So that would imply minus 12a. Well, let me distribute it first. Minus 12a plus 6b cosine x plus 6c sine x equals 3 minus cosine x. Combine the like terms. So if I combine the cosine x terms, six b minus c times cosine x, b plus 6c sine x would equal 3 plus minus 1 times cosine x plus 0 times sine x. So by direct comparison, minus 12a is 3, 6b minus c is minus 1, b plus 6c is 0. Minus 12a is 3, which would imply a is 3 over negative 12, which is negative 1 over 4. 6b minus c is negative 1, and b plus c would equal 0. Now, naturally, this would mean b is negative 6c. So take that, plug it in this equation. 6 times negative 6c minus c would equal minus 1. So we have negative 37c equals minus 1, which would imply c is 1 over 37. Take that and plug it in b. We have minus 6 times 1 over 37, so we have negative 6 over 37. So the particular solution is yp equal to a negative 1 over 4 x squared plus b cosine x plus c sine x. And the general solution is y equals the complementary part, which is c1 plus c2x plus c3 e raised 6x minus 1 over 4 x squared, the particular part, minus 6 over 37 cosine x plus 1 over 37 sine x. So here we have another third order differential equation. So as always, we start with the associated homogeneous equation. The associated homogeneous equation is y triple prime minus 3y double prime plus 3y prime minus y equals 0. The auxiliary equation is m cubed minus 3m squared plus 3m minus 1 equals 0. I've demonstrated this in one of the previous videos on how to find the factors. If you have a cubic polynomial, of course, we could go back and look at it, or we could use the calculator to find it. But if you have a good algebraic background, you can see that this is simply m minus 1 times m minus 1 times m minus 1. And that would imply m1 is equal to m2 equal to m3. They're all 1. So the complementary solution is yc is c1 e raised 1x plus c2 x e raised 1 times x plus c3 x squared e raised 1 times x. So we have c1 e raised x plus c2 x e raised x plus c3 x squared e raised x. So now that we have a complementary solution, our objective is to find the particular solution. The right-hand side is g of x equal to x minus 4 e raised x. So I look at, therefore, the form of the particular solution is yp. I have a linear term, so I have to put ax plus b. Now, the next term is 4e raised x, but we cannot simply put c times e raised x because we already have c1 e raised x. So you may say, okay, let me do c times x e raised x. So that is the usual procedure. But we can't use that either because we've used c2 x e raised x already. So you may say, okay, well, I could add c times x cubed e raised x, x squared e raised x, but I've included that too also. So the only option that I have here is to write c times x cubed e raised x. So now we have to find the first derivative. That would be a derivative of the constant is 0, c times x cubed e raised x plus e raised x times 3x squared. So we have a plus c e raised x multiplied by x cubed plus 3x squared. The second derivative would make a 0. We have c e raised x, 3x squared plus 6x plus c x cubed plus 3x squared times e raised x. And yp triple prime c e raised x 6x plus 6 plus 3x squared plus 6x multiplied by c e raised x. And the last term we have c x cubed plus 3x squared e raised x plus c e raised x 3x squared plus 6x. Now we have to plug it in the original equation to get the terms isolated. So plug in you plug in all of those values in the DE. Now before that, let's see if it is necessary. We definitely need the x terms and we need the e raised x terms. So what would give us the x terms in this particular equation? So in the third derivative, so let me go ahead and write the original DE. It's yp triple prime 3yp double prime plus 3yp prime minus yp equals x minus 4 e raised x. Now you just have to observe the right hand side to get the necessary equations, because we don't want to have too many terms in trying to find the particular solution. So as long as I get enough equations to solve the coefficients, I am perfectly fine with it. So how would we go about doing this? Well, I have an x term here, so I'm going to pick out all the terms that would result in an x, and e raised x also. In the third derivative, I am going to get 6c e raised x. So that is one term that I need. Do I need the other terms? And I have another one. Do I have another one? No. That's all I need there. And move on to the second derivative. I have an e raised x term. So nothing of consequence there. And now you've got to be careful. We should be able to get enough equations to find the solution. If not, we have to go back and plug the values in to get to the correct answer. So I'm going to skip yp double prime altogether for now. Then I'm going to look at yp prime, and the terms I need would be 3 times just the constant term. I don't think I need the constant term either, because I don't have a constant in the solution. So we'll get rid of that. And yp, I simply have ax, and that is it. Is that all? And looks like that is not going to give me enough equations. So I certainly can equate 6c minus 4 equals e raised x. The second derivative isn't giving me any e raised x terms. And the first derivative just has an a term. But what we can do is make use of the first derivative. I just need the constant part from that. So I'm going to skip the second derivative. I'll move on to the third. I'll have 3a. And in the first one, I have the x term, and I have the ax plus b term with a minus. So what I can do now is I could combine 6c e raised x 3a minus b minus a x x minus 4 e raised x. This is a crucial step. I can't stress this enough. You really don't want to plug in all of this in the equation here in order to find the constants a, b, and c. You just have to be wise, because I just want coefficients corresponding to these terms, the x and e raised x and constant terms. As long as you have enough equations, we could find a solution. So now by direct comparison, I can see negative a must equal 1. There is no constant term here, so 3a minus b would equal 0. And the coefficient here for e raised x is 4. And on the left-hand side, it is 6c. So 6c e raised x, or simply 6c, would equal to negative 4. So now we have 3 nice equations, so we can easily find the solution. This would imply a is negative 1, b is 3 times a, and c is negative 4 over 6, which is negative 2 over 3. So b is minus 3. So the particular solution, now that crucial step comes with practice. So the more you practice, the easier it would be for you to pick out the right terms and not spend too much time in finding the undetermined coefficients with the superposition approach. So the particular solution, yp, is negative x because it is ax, plus b, so minus 3, plus c, negative 2 over 3, x cubed, e raised x. So the final solution y equals c1 e raised x plus c2 x e raised x plus c3 x squared e raised x minus 2 over 3 x cubed e raised x minus 3. I could pull the e raised x out. I will have c1 plus c2x plus c3x squared minus 2 over 3x cubed minus x minus 3. Now we are getting into higher order territory. So the associated homogeneous equation is y, fourth derivative, plus 2 second derivative, plus y equals 0. The auxiliary equation is m raised 4 plus 2m squared plus 1 equals 0. Of course, you could use a calculator to find the solution here, but I'm going to show you an algebraic way with substitution because this is an easy equation. So let u equals m squared. This would mean m raised 4 is m squared squared plus 2m squared plus 1 equals 0. Replace the substitution, we would have u squared plus 2u plus 1 equals 0. That is an easy quadratic equation, and the solution is simply u plus 1 times u plus 1. So the two possible values for u are minus 1 and minus 1. They are repeating, but u is m squared, so if m squared is minus 1, this would imply m is square root of plus or minus 1, so that would be plus or minus I. The same applies over here also. M squared is minus 1, which would mean m is plus or minus I. So m1, m2 are I, m3, m4 are minus I. So we have betas and we have negative betas, and they are the same, and they are repeating conjugate roots. So the complementary solution so the beta is 1. They are conjugate paths, so you can't put negative 1. So the complementary solution, we know in this case, is e raised alpha x, a cosine beta x, plus b sine beta x, plus, or stick with C1, C2, C1, C2. Now, these are repeating solutions, so we have C3, x cosine beta x, plus C4, x sine beta x. Alpha is 0, so y is e raised 0x, C1 cosine x, C2 sine x, C3 x cosine x, plus C4 x sine x. So we have all the parts for the complementary equation. So y c is c1 cosine x plus c2 sine x plus c3 x cosine x plus c4 x sine x. Now we have to find the particular solution. How do we go about finding the particular solution? We look at the right-hand side. The right-hand side is and you look at that and you say, well, that doesn't look nice. Doesn't fit the standard format, but if you FOIL it, you would see g of x is simply x squared minus 2x plus 1. Therefore, the form of the particular solution is yp equals ax squared plus bx plus c. Now we could find the first derivative, second derivative, and the fourth derivative to plug it in the equation. So yp prime is 2ax plus b. Even though this is a fourth order equation, this problem is pretty straightforward. We have 2a. Yp triple prime is 2. yp fourth derivative is simply 0. So plug in the values, plug in yp fourth derivative, the second derivative, and yp in fourth derivative. Is it minus? Plus. So the fourth derivative is 0, so we don't have to worry about that. Moving on to the second derivative, we have 2a. Then we have ax squared plus bx plus c, and that is equal to x squared minus 2x plus 1. So we have 4a plus ax squared plus bx plus c equals x squared minus 2x plus 1. Something feels amiss to the first derivative, the second derivative, the third derivative, fourth is 0. Have the strange feeling that I'm doing something wrong. Let's see. Second derivative is 2a, and I have a 2 in front of it, and have plus y plus yp. So let me combine and see what happens. So I would have ax squared plus 4a plus b times x plus c equals x squared minus 2x plus 1. Now I could do a direct comparison. So I have the coefficient of x squared is 1. Yeah, it makes sense. So compare 4a plus b equals negative 2, coefficient of x, which would imply 4 plus b is equal to negative 2. B is negative 2, negative 4. We get negative 6. And C happens to be 1. For A plus B. So the solution the particular solution yp is equal to a, which is x squared, b times x, negative 6x, and c is simply 1. So the final solution, y is equal to the complementary part, c1 cosine x plus c2 sine x plus c3 x cosine x plus c4 x sine x plus x squared minus 6x plus 1. And that is the final answer. So now we can extend the same idea that we have for solving the differential equations using the superposition approach to initial value and boundary value problems. So here is a simple initial value problem. Now we're going to solve this using the method of undetermined coefficients because the right-hand side is negative 2, which means it is a non-homogeneous equation. So the associated homogeneous equation is y double prime plus 4y equals 0. So the auxiliary equation is m squared plus 4 equals 0, which would imply m squared equals minus 4, which would imply m1 is 2i and m2 is minus 2i, complex conjugate pairs. So the complementary solution is y is equal to c1 cosine 2x plus c2 sine 2x because alpha is 0 and beta is 2. Now we have to go for the particular solution. So the particular solution in this case is simply a constant. We have the right-hand side to be negative 2. So since it is a constant, we know from the table earlier that we can directly plug in A and then solve for C1 and C2. So that's exactly what we are going to do. Whoa. So yp is simply some constant a. So where am I getting this from? I'm getting that from over here. If the right-hand side is any constant, the form of the particular solution is simply a. So if I plug that in, I will get y p prime plus 4y p equals minus 2, which would imply, well, yp prime is 0, yp double prime is also 0, so 0 plus 4a would equal negative 2, which would imply a is negative 1 over 2. So the general solution to the DE, the solution to the DE is YC, or Y equals YC, which is C1 cosine 2x plus C2 sine 2x minus 1/2. Now, we use the initial conditions to find C1 and C2. Y of pi over 8 is 1 over 2. And the other condition is y prime of pi over 8 is 2. So we have to find y prime. So y prime is 2c1 or negative 2c1 sine 2x plus 2c2 cosine 2x. And the derivative of minus half is 0. So using the first condition, one half would equal C1 cosine 2 times pi over 8 plus C2 sine 2 times pi over 8 minus 1/2. And if we add 1/2 on both sides, that gets C1. Well, the 2 and the 8 would go away. We have pi over 4. And cosine pi over 4 is 1 over square root of 2. And it is the same for both sine and cosine. So I will have 1 over square root of 2 times C1 plus C2. So we get C1 plus C2 is simply equal to square root of 2. Y prime of pi over 8 is 2. So we have 2 is equal to minus 2c1 sine pi over 4 plus 2c2 cosine pi over 4. I'm using the same trick like I did in the previous part. Divide by 2 on both sides. I have 1 equals minus c1 multiplied by 1 over root 2 plus c2 multiplied by 1 over root 2. Multiply by square root of 2 on both sides. Square root of 2 would equal minus c1 plus c2. And now we have two equations, so we could find the two constants. So c1 plus c2 is equal to root 2. Minus c1 plus c2 equals root 2. If I add them together, 2c2 would be equal to 2 root 2, which would imply c2 is simply root 2. Clearly, that would make c1 0. So we have the value of c1. Oh, not boundary. Initial conditions. Is y. C1 goes away. C2 is square root of 2 sine 2x minus 1/2. And that comes from the particular solution, minus half. So the purpose of having the initial conditions is to find the arbitrary constant C1 and C2 in the complementary solution. Here is another initial value problem involving a third order non-homogeneous equation, and we start with the associated homogeneous equation as always. Y triple prime minus 2y double prime plus y prime equals 0. So the auxiliary equation is m cubed minus 2m squared plus m equals 0. So we have an m in common. Take that m out. M squared minus 2m plus 1 equals 0, which I can then write it as m times m minus 1 times m minus 1 equals 0, which would imply the roots are m1 equals 0, m2 equals 1, and m3 equals 1. So the complementary solution is y equals c1 e raised 0x plus c2 e raised x plus c3 x e raised x, which simply is c1 plus c2 e raised x plus c3 x e raised x. Now, we have to find the particular solution. So the right-hand side, g of x is 2 minus 24 e raised x plus 40 e raised 5x. The form of particular solution is yp. I see a constant here, but I can't simply put a because I already have a constant there. So I have to put a times x. I see e raised x, but I can't simply put e raised x because I have it here. I can't simply put x e raised x because I have it there. So I simply have to do b x squared e raised x. I don't see a 5 raised x term, so I could simply put x e raised 5x. So that is fine. Now we have to find the derivatives. Yp prime is a plus b e raised x times 2x plus e raised, x squared times e raised x plus 5c e raised 5x. Yp double prime, the first derivative is 0. The first constant would become 0. So I'd have 2b x e raised x plus e raised x, product rule, plus b e raised x times 2x plus x squared e raised x plus 25c e raised 5x, which I could write it as 2b x e raised x plus 2b e raised x, 2b x e raised x plus bx squared e raised x plus 25c e raised 5x. I could combine a few terms here. I'd have 4b x e raised x plus 2b e raised x plus bx squared e raised x plus 25c e raised 5x. And yp triple prime is 4b x e raised x plus 2b e raised x plus b 2x e raised x plus x squared e raised x plus 125c e raised 5x. So that would give me 6b x e raised x plus 4b e raised x. It's not just x, it should be e raised x. Plus 2b e raised x plus b x squared e raised x plus 125c e raised 5x. Combine a few terms, I'd end up having 6b x e raised x plus 6b e raised x plus b x squared e raised x plus 125c e raised 5x. Now, we have to plug yp triple prime, yp double prime, and yp prime in the DE, which is yp triple prime minus 2yp double prime and y prime. And we can see we have some lengthy expressions here, so this becomes a very crucial step because we're going to pick and choose as to what terms we have to plug in. So this is a crucial step. We are going to put in terms selectively so that I make sure that I have terms corresponding to the right-hand side instead of plugging in every possible term that I can think of. So let's see the terms that we can't use. We have a constant term, so we will get to that. We have an 24 e raised x. So we need to collect terms that have e raised x, and we need to collect terms that have e raised 5x, and a constant term. So with the third derivative, I'm just going to pick 6b e raised x, 125c e raised 5x. With the second derivative, I'm going to pick 2b e raised x and 25c e raised 5x. First derivative, I am going to pick the constant because I need the constant. So b, and that would be it. Except for 5c e raised 5x. And that should equal to 2 minus 24 e raised x plus 40 e raised 5x. So add all the terms, distribute, simplify. 6b e raised x plus 125c e raised 5x minus 4b e raised x minus 50 c e raised 5x plus a plus 5c e raised 5x equals 2 minus 24 e raised x plus 40 e raised 5x. So combining the terms, I have 2b e raised x plus 8t c e raised 5x plus a equals 2 minus 24 e raised x plus 40 e raised 5x. By direct comparison, a would become 2, b would become negative 12, because 2b is 24. I'm comparing that term to that term, so 2b is negative 24, which would mean b is negative 12, and ATC is equal to 40, which would imply C is 40 over 80, which is 1/2. So the particular solution is yp equal to a, which in our case is simply 2x minus 12x cubed e raised x. Or is it x squared? It's x squared, I'm sorry. Plus 1/2 e raised 5x. So the solution is the sum of the complementary function, which is c1 plus c2 c3 x e raised x, and the particular solution 2x minus 12x squared e raised x plus 1/2 e raised 5x. That is the solution. Now we make use of the initial conditions to find C1, C2, and C3. An initial value problem is no different from a boundary value problem. The only difference is instead of initial conditions, we have boundary conditions, and typically initial value problems involve several derivatives. Boundary value problems, not so much. Other than that, the process is the same. The objective is to find C1, C2, and C3. So we have y of 0 is equal to 1/2. That is our first condition. Y prime of 0 is 5 over 2, and y double prime of 0 is negative 9 over 2. So y of 0 is 1/2, so that would equal to C1 plus C2. The second, third, fourth term would become 0, and we simply end up having 1/2 e raised 0. So C1 plus C2 would equal 0. We need to find the derivatives. So y prime is C1 goes away, C2 e raised x, C3 x e raised x plus e raised x plus 2 minus 12 2x e raised x plus e raised x times x squared plus 1/2 5 e raised 5x. Now y prime of 0 is 5 over 2, so we have C2 plus C3 plus 2, the next term would go away, plus 5 over 2. This would imply C2 plus C3 is negative 2. Y double prime of 0 is c2 e raised x plus c3 x e raised x plus e raised x plus c3 e raised x, derivative of 2 is 0, minus 12 times 2 times x e raised x plus e raised x plus e raised x times 2x plus x squared times e raised x. I'm using product rule multiple times, plus 25 over 2 e raised 5x. And that happens to be negative 9 over 2 and y double prime of 0 is negative 9 over 2. So we have c2 plus c3 plus c3. First term goes away and I have a negative 24. So I'm right here. That term will go away, that term would go away, and I'll have 25 over 2. Move things to one side, so we would have negative 9 over 2, negative 25 over 2 plus 24. That would equal to c2 plus 2, c3. Negative 17 plus 24 equals c2 plus 2c3. 7 would equal to c2 plus 2c3. That is one equation. The other is from earlier, c2 plus c3 equals negative 2. Subtract the 2, we would have 9 equals c3. Take that value, plug it in one of the two equations. This would imply 9 plus c2 equals minus 2, which would imply c2 is minus 11. And we know that c1 is equal to minus c2. That is from that step over there. We can simply plug that value in and we would end up getting c1 to be plus 11. Therefore, the solution for the DE satisfying the initial conditions is y equal to c1, which is 11. We are plugging it here. c2 is minus 11. c3 is 9. There is no c4, the rest would be the particular solution, and the particular solution is what we had earlier, which is right over here, 2x minus 12 x squared e raised x plus 1/2 e raised 5x. And keep in mind, a boundary value problem is no different from an initial value problem. The process is pretty much the same. At the end of the day, we have to find the arbitrary constants that would satisfy the conditions.